Let's continue our math adventure. We know that we've been working a little bit with probability, and we know that probability can be written as a ratio, where we have the event or what we want to have happen on top, and the outcome is all the possible ways that that thing can happen. Well, we're going to work on something called the counting principle today, and it's directly connected with the outcome, or that bottom part of our probability ratio. So what the counting principle really does is it gives us a really fast way that we can calculate that outcome. So sometimes our probability is a little complicated. Let's just talk about putting outfits together. Say in your closet you have two pairs of pants. One is a blue pair of pants, one is a khaki pair. And then let's say we have three shirts. We have a red shirt, a yellow shirt, or a green shirt. Well, I want to know all the ways I can put those outfits together. So that total possible ways has to be that bottom part of my ratio. Well, I could draw the tree diagram, and that's exactly what I did here, where I'm listing out those ways. And when I draw that, I'm going to put my two kinds of pants on top, and then I'm going to put my shirts on the bottom. And then what we can do is we can see all the ways we can put our outfits together. We could have blue pants with a red shirt, or we could have blue pants with yellow shirt, or we could have blue pants with a green shirt. But maybe we don't want our blue pants, maybe we want to wear a khaki pants. So we could have khaki with the red shirt, khaki with the yellow shirt, or khaki with the green shirt. If I want to see all the ways I can put those outfits together, all I have to do is read that bottom line of the tree diagram. And if I count that up, I have 1, 2, 3, 4, 5, 6 total outfits that I could create. But drawing tree diagrams can kind of be a hassle sometimes. So mathematicians found a faster way, and they called it the counting principle, that we could go and we could figure out those outcomes without drawing it all out. So what we do is we take the number of pants options. So the first number of options we had was 2. And we take the number of shirt options, and those shirt options were 3. And if we multiply those together, that gives us also our 6 outfits. So it's just a real fast way to calculate where we don't want to draw. Now, the concept of license plates works exactly the same way. We would never want to draw a tree diagram with license plates. So say we take a license plate that has 3 numbers and 3 letters with it. Well, if we want to find the total number of possible license plates there are, or that bottom number, we're going to use that counting principle. So if we take a look at the numbers, there's actually 10 digits we can use. We can use 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So there's 10 options with the numbers. So for my first number, I have 10 options. Second number, I have 10 options. Third number, I have 10 options. But I'm not done, because now I have letters. And for each of my letters, I have 26 options to choose from. So when I go to calculate this and I multiply 10 times 10 times 10 times 26 times 26 times 26, I get 17,576,000 different license plates that could be made using 3 numbers and 3 letters. Now, how many of those license plates would be yours? Well, only 1 out of those 17,576,000 license plates. That's why license plates are such an ingenious way for us to actually register or document all the cars that are on the road. It's a prime example of where the counting principle is used. Phone numbers are also an example of that. So it is your turn to try to use the counting principle to create these probability ratios, focusing on how to come up with these outcomes in a very quick and resourceful way. Good luck. It's up to you.